Right, so in this part of the video, we'll continue with another example, example 5, where we are asked to determine a series solution about x not equals to 0 for the following initial value problem. Okay, so yeah, the given DE is this, y double prime minus 2x y prime plus y equals to 0, and the initial value given are when x equals to 0, y equals to 1, and when x equals to 0, y prime equal to 1. So yep, let's look at this. The first condition is that when we compare this with the standard form of the differential equation, we can see that the px equals to 1, thus all points would be an ordinary point for this particular differential equation, so x not equals to 0 can be worked on. Right, so then let's continue. So the proposed y would be, so yx equal to the summation from n equals to 0 to infinity, an. Because x naught is equal to 0, so x minus x naught just becomes x. So we just put x here to the power of n. And then the y prime will thus be summation from n equals to 1 to infinity, n times an, x n minus 1. And the y double prime would be summation from n equals to 2 to infinity, n times n minus 1, an, x n minus 2. So we plug in this y prime, y double prime, and y into the differential equation to, to just solve the thing. Minus 2x times the summation plus the y itself Yep. So then the next part is to move all coefficients into the inside of the summation. So the first term, we don't have to do anything, but the second term here, we need to put the 2x inside, and the third term also we don't need to do anything. So let's just follow on. So the 2, we can put it outside. And then the x now is just n, because n minus 1 plus 1 is just n. And then the third term also stays the same. Right. So the next term is to make sure everything starts from all the n are to the power of n, all the x's are to the power of n. So this term already x to the n, this also x to the n. So we need to tweak the first one, the first series. So this one is plus 2. So here is plus 2, plus 2, plus 2, and minus 2 at the bottom there. So now we have the series, the first one starting from n equals to 0, and then n plus 2, and then n plus 1, a of n plus 2, and then x of n minus, now n starting from 1 to n, an, x of n plus this one. Okay, so the next step is to strip out the terms with n equals to 0 so that all of the series starts with the same starting point. So we want all the series to start at n equals to 1. So we take out the terms with n equals to 0 for the first and the third series. Okay, so for the first series, when n equals to 0, you have 2 times a2. And then you can write down the remainder. And the second term maintains starting at n equals to 1. And the third term, we need to take the term with n equals to 0 out. So you will have x naught out plus the remainder, which is n equals to the summation from n equals to 1 Right. So now we can collect the terms and factorize the xn. So now we take out a0 and 2a2 together. So a0 plus 2a2 plus the summation from n equals to 1 until infinity. Then we can factor out xn. So the inside would be the coefficients n plus 2, n plus 1, a sub n plus 2 minus 2n an plus an, everything times xn equals to 0. Okay. Next is we make the equations all equal to 0 so that we can work out the value and see the trends. Okay. So set the equation all equals to 0 when n equals to 0. A0 plus 2a2 equals to 0. And then when n equals to 1 and 2 and 3 and so on, the coefficient n plus 2 times n plus 1, a n plus 2 minus 2 and a n plus a n will be equal to 0. Then we need to solve these two equations, the first and the recurrence relation. So the first one is a0 plus 2n2 equals to 0. That will give us a2 equals to minus a0 over 2. And then for, this is for n equals to 0. So for n equals to 1 and 2 and 3, so on and so on, you have a n plus 2 equal to, well, you can factorize this a n out and you have 2n minus 1 and then divided by n plus 2 and n plus 1. Okay. Then for n equals to 1, you have a3 equals to 2 times 1 minus 1 is just 1, and a1 over 3 times 2. So you have a3 equals to a1 over 6. Then n equals to 2. So a4 equals to 2 times 2 minus 1 is 3. a2 over 4 times 3. So you have a2 over 4. And a2 is this one. Okay, a2 is equal to a0 over 2 minus. So equal to a2 over 4 times 2 minus, no, a0. So that will give you minus a0 over 8 for a4. Then n equals 3. So n equals 3, a5 equals to 2 times 3 minus 1 is 5, a3 over 5 times 4. You have a3 over 4. Then a3 is what? a3 is this, a1 over 6. So it's a1 over 4 times 6. So a5 is a1 over 24. So yeah, you can see that the pattern already. So it's all in terms of a0 or a1. Then we can get the solution already for this particular problem. So y of x in the series form was this. Then when you expand, you will get a0 plus a1x plus a2x squared plus a3 x cubed plus and so on up to you really. I mean, since we have until a5, so I mean, maybe I'll stop at a5. Yeah. So then we can put in the values that we know. I mean, not the values as in the actual values, but what in terms of what, since we have everything in terms of a0 and a1. So a0 here and a1 here maintained. So a2 A2 is minus A0 over 2 x squared plus A3 is A1 over 6 x cubed plus A4 is minus A0 over 8 x4 plus A5 is A1 over 24 x5 and so on and so on. And you can collect all the terms together. So you collect those terms with A0. So take out A0 and 1 plus or minus x squared over 2 minus x to the 4 over 8, so on and so on, and plus with A1 times, inside here starts with x, and then plus with x cubed over 6, plus with x5 over 24, and so on and so on. Okay, so now since we are given the initial condition, so we can work out what are the values of A1 and A0. So we can apply the initial value. So the initial value given is y at x equals to 0 is equal to 1. So from here, when you put x equals to 0 inside the series here, you will get, so 1 equals to A0 times 1 plus 0 plus 0 plus 0 and everything. And then A1 times 0 plus 0 plus 0, everything. So you will just get 1 equals to A0. So this is your value for A0. Then you can use the other initial condition given, which is y double prime at x equals to 0 equal to 1. So from the yx here, you can get sort of yx in terms of a and a1. But we're not really interested in the a0 terms because we already know the a0. So let's just look at, just look at the terms with a1. So when you differentiate the terms starting with a1 here, you'll get a1 and then plus a1 times 2x3 over 6 plus a1 times 5x to the 4 over 24 and so on and so on. Well, you can see the trend that starting from this point onwards, when x equals to 0, everything will be equal to 0. So you can concern yourself with this A1. Wait. Did I get this right or not? So wait. Let me just, if I differentiate with the terms with A0, so A0 and then y prime, then A0 times 2x over 2 minus A0 times 4x cubed over 8 and so on and so on. So I still have this value of A0 here, right? No, here don't have. Okay, yeah, I just want to double confirm. So we don't have to concern ourselves with the value of A0 here because everything will vanish at the differentiation at the A0 terms. So then we will put 1 when x equals to 0, 1 equals to A1. So then A1 is equal to 1 also. So then we can put these values back into the this equation here. So then we get y of x equals to just 1 minus x squared over 2 minus x to the 4 over 8 and so on plus x cubed over 6 plus x4 over 24, not x4, x5. Okay, and so on. So that's it really. So meaning here, when you're given a problem that you are given, you're given a differential equation that with the initial conditions, and then you need to find out what could be the values of your coefficients. Okay. Okay. We'll continue the next video with the singular points.